All right, so we've done some cluster analysis. Now, what do we do with this for our business? So how do we actually use cluster analysis for business decisions? Well, this multi-step process that you see here comes from Evie Fowler of Fulcrum Analytics, a marketing research company in the US. And this is the process that she recommends for how you can use cluster analysis to actually make decisions for your organization. So let's walk through an example of this. So what we would do is we would first explore the data set with graphs and descriptive statistics, so better understand what is happening. We would perform some feature engineering to choose potentially relevant variables. Here's where our inferential statistics could come in, testing whether or not there's a statistically significant relationship between variables. So we're trying to narrow down which variables in our data set are relevant for our cluster analysis. That's what's called feature engineering. Perhaps we'll talk to content experts because we have people within our organization who want us to do this work, who probably have an opinion as to what variables they want. Maybe it's the variables that are actually actionable, right? So we might collect a bunch of information, but in terms of being able to work with to identify as new customers come in, for example, which cluster they belong to, these are the ones that we think would be the most relevant to that or the easiest to get in information to help do the clustering. So we talk to the content experts to make sure we include the variables that they want. Then what we're going to do is perform some machine learning based clustering, and we could use our, that's not correct. I should say k-means, not KNN, because KNN is a classification model, not a clustering model. So k-means is the one that we looked at. dbScan we're going to talk about in our next video. The agglomerative one is the one we just did. So really that should say, I really hate all these typos, are just killing me. K-means. Okay. So we would perform our clustering method, and then we would use our silhouette coefficient, our Kolinsky-Hurwitz, and our Davies-Bouldin to identify the number of clusters, and we apply the clustering methods to get those labels. Once we have those labels, then what we would need to do is to, especially if we have lots of variables, we're now going to need to narrow it down further. Because while lots of variables will help us identify the potential clusters, the problem is that in real life, it's difficult to action on lots of different variables. So what we would do is plot some density plots or violin plots for each feature or variable combination. Are there clear differences? So we're looking for clear separation. So if we were to plot two of the variables, for example, in a scatter plot, where we color-coded the labels that our cluster analysis gave us, is there a nice clear linear split? Which means, so for example, if this is company size, big company, little company, we could then action that into decisions where we would treat these groups differently. So we're looking for nice linear splits on variables and combinations of two that would align with the clustering. That would then help us act on this. And so we can find that by first plotting density plots or violin plots to look for clear differences, and then pick combinations of two to look for nice, easy separations to help us with that process. So we want to ultimately identify no more than 3 features or variables that can be linearly split. We really would like to get it down to 2 if we can. Because what you can see then is that even if you only had 2 features, so here's a feature, here's a feature, or variable and a feature, and you split, that's already 4 clusters. So 2 variables is 4 clusters. You can see as we start adding more and more variables, 3 dimensions, 4 dimensions, it's a lot more clusters. And again, as we talked about in the previous video, we need to ask ourselves, how can we use this information? Can we actually treat those cohorts of customers differently? Can we actually do something different with those different groups of union members? So too many clusters is a problem. So what you're trying to do is find the best variables to identify clusters and then look for easy ways to define that separation, those ones that have a clear difference, so that we can make a very simple business rule, a very simple decision process that says, if this, then do this, if that, then do that. So we're trying to simplify it down. So we want to get down to, if we can, no more than 3 features or variables, 2 preferred because that's already 4 clusters. Then if you have some holdout data, how accurate is your simplified model? Does it make sense where it put them? Let's give the clusters names and translate those splits into some business rules in terms of how we would act. If this happens, then that happens. So let's walk through that process. So we're going to use the database here, the e-commerce one. So just a reminder, you can find cluster analysis here under drstephpowers.github.io/BIA cluster analysis. And for our business use case here, what we're going to be doing is we are using this e-commerce customers.csv. So what you'll want to do is download that file, put it in your Google Drive, open this Python workbook in Google Colab, save a copy, log in, and then mount your own Google Drive, tying this workbook to your workbook, to wherever you put the data set. And so we're loading in ecom as that e-commerce customer data set. This data set comes from Kaggle. All right, let's give this a try. So first, because I have already tied it to my Google Drive and I've already imported it from using that read.csv or read_csv, I can then just say, show me the top of the table. So this e-commerce database here has the email and address of an individual, their online avatar, the average session length, the time they spend on the app, the time they spend on our website, the length of the membership, the yearly amount spent. We're looking for, if we take these variables, can we find clusters of customers? And so what we're going to do is let's do k-means for this particular one here. Okay. You could do, if you would rather, you could do your hierarchical instead. Okay. From sklearn.cluster import k-means, or if you're doing the agglomerative one, then make sure you're importing the relevant package for it. From sklearn.metrics, we are importing our silhouette score, our Kolinsky-Hurwitz, and our Davies-Bouldin score. We are going to choose to use average length of session. We're going to use time on the website, length of membership, and yearly amount spent. Remember, if you're doing k-means, your data has got to be ordinal or your data has got to be interval or ratio. K-means does not work with ordinal data. Now, this particular data set doesn't have any ordinal, so we're okay to use the k-means for this. All right, so x is equal to, and we use NumPy, so make sure you import that one as well. Okay. So we import our packages. We're going to create an array using NumPy, and it's going to pull from our ecom database, average session length, time on app, time on website, length of membership, and yearly amount spent. These match the labels that are at the top of this table. Okay, so let's pull that. And let's build a loop like we did in our previous video, where it takes a number of different clustering options, because we really don't know. Are there 2 clusters? Are there 9 clusters? All right, number of clusters, 2 through 9. And then we're going to create our loop. So we're going to create an empty list called compare. And then we're actually going to, I'm going to simplify this, range parentheses length. You really don't need that. I mean, you can do it that way, but you can also just simplify this to for I in number of clusters, because it's going to go 2, 3, 4, 5, 6, 7, 8. K-means equals, and then call the package k-means. The number of clusters is just going to be equal to I, because it's going to go through this list here. And then each time it's going to set the number of clusters. It's then going to fit it on our X data. It's going to pull the labels. Then it's going to take the labels and it is going to find the silhouette score. Then it's going to find the Kolinsky-Harbut score. Then it's going to find the Davies-Bouldin score. And then it is going to append. So this is the same loop we did before, where it's going to create a table where it lists the number of clusters, the silhouette score, the Kolinsky-Harbuts, and the Davies-Bouldin. And we're going to append that to this empty list. Then take that list and turn it into a data frame, into a table. So you'll notice we're using pandas here. So we need to make sure we also have imported pandas as PD. Make sure we have everything we need. And then we're going to add column names to that new table. We'll call it number of clusters, SIL score, CH score, DB score. All right, run it. All right, too many pieces. There we go. Actually, it all needs to be in brackets. I got rid of one too many brackets. So when you do append, it's expecting you to append one thing at a time. If you are appending more than one thing, like here we're appending multiple things, there needs to be these hard brackets around it. All right, now let's run the sucker. Okay. All right. Then let's call the table. What does it say? It says, when we look at this, we can see not a huge amount of difference here. We are looking for the silhouette score. We're looking for a bigger number, 53538, so maybe 5 clusters. The Kolinsky-Harbuts, remember, it likes more clusters, so it says we should have 6. Okay, and the Davies-Bouldin, we're looking for a lower number here, so find the lowest number. It says the lowest number here is 6. So here we have 2 that say we should have 6 clusters and 1 that says we should have 5 clusters. So then I go 5, go with 6. We can go with 6 clusters here. Okay. So if we do that, if we do our 6 clusters, we do k-means, we tell it to do 6 clusters, and we fit the data, and we get our labels. Okay, so here now we have our e-commerce data is labeled with our 6 clusters. We're actually going to add a column to the chart, to the original table, and we're going to call that label. This is allowing us to kind of add onto the table what of the 6 categories it belongs to. All right, so let's do that. Okay. Now, if we go back to what E.V. Fowler recommended in terms of our process, so let's assume we've explored the data set and done our feature engineering, which led us to that e-commerce data table that we had. We talked to content experts, also led to that data table that we had. And so now we're going to do our k-means. Then we used our silhouette, Kolinsky, and Davies-Bouldin to identify the number of clusters. We did that. We got 6. Now we applied the clustering method. We got the labels. We are appending that to the table. The next step in the process is to plot some density plots or violin plots for each of the variable or features by cluster to look for clear differences. Okay, so we're going to do that next, right after I append it to the table. Okay. So then if we looked at, for example, ecom.head, what you see now is there is this new column here that says this is group 1, group 3, group 0, and so on. Okay, so according to E.V. Fowler, what we should be doing next is that we should be then creating some violin plots. So let's do that. So from Seaborn, import violin plot. We've done this before from our data visualization video. And so here we're going to take our ecom database, our table. X is going to be our label. That's that new column we just created. And then let's look at some of the variables. So let's start with average session length. If we look at average session length, and then the y-axis is average session length, the X label is cluster. What we're looking here is we're looking for, is there clear separation? Is there clear differences in them? Plot density plots or violin plots for each variable. Are there clear differences between the clusters? When we look at this, you can't see my hand, but if I stick my arm across the middle, right around here, notice all those box plots, they really overlap. There's maybe one that's slightly different, not even sure. A lot of overlap here. So while this variable was used to create these clusters, it's not having a huge impact on the clustering. So let's try a different variable. So if it's not going to be average session length, maybe it's going to be time on app. So we take our ecom database, we're taking our labels, we're taking the time on the app, and we will create our violin plot. They updated the violin plot, and now the default is just one color instead of multicolors. It's just not as pretty. You have to go in and change the color settings, which I think we did in the violin plot video, to make it change. So for here, we'll just keep it quick and simple. All right, looks like here maybe there's a difference. Cluster 2 looks like they're spending less time on the app. Still a lot of similarity between these different clusters. All right, what about time on website? So we'll create a violin plot and we'll use our ecom data. Our labels are going to be on the horizontal. Our time on the website is on the vertical. Ugh, no change. So definitely not that variable in terms of creating our decision or business rules. That's not helpful at all. Okay, what about the amount of time they spend yearly? So can we use that to help us separate out these clusters? So I'll create a violin plot using the ecom table, labels on the X, yearly amount spent on the Y. Differences. So notice that these groups have considerable difference among them. And so this variable is one where we could build a decision rule around. Okay, let's see. Let's go through, might as well go through the rest of the variables, right? Okay, so yearly amount spent, we're going to hang on to that one. Let's look at some of the other ones. How about length of membership? So ecom data table, X is the label on the horizontal, vertical is the length of membership. Looks like there's some differences here too, right? We can see that if we look at the medians, they are different. So length of membership, yearly amount spent, these two variables we could use to build some decision rules. So those are probably the two we want to use as we follow the process here in terms of plotting scatter plots to see how we would, if there's any clear splits, and how we could make some decisions about that. Before we do that though, let's just do one more visualization, and that's the radar plot. So we've created radar plots before. We have a video on how to create these spider or radar plots. And we can create them using plotly.graph_objects as go. Okay. Now, because the data that we have here is ratio, when we built our spider or radar plots before, we did it with ordinal data. Here, when we're doing it with ratio data, each of these variables has a very different measurement, right? In terms of the average, in terms of the variability, they're on different scales. And so we need to standardize them if we're going to build a spider or radar plot. So we're going to define standardize, and then we're going to standardize the column of data. And we're going to take the column's values minus the column's average divided by the column's standard deviation. So this calculation where we take the value in whatever row, subtract the average of the column and divide by the standard deviation of the column helps us in terms of standardizing the data. So we're going to create that function there. Okay, we'll have a function standardize. And then what we're going to do is we're going to apply that function. So we're going to apply standardize, and we're going to apply it to all of these columns we're using in our cluster analysis. So ecom is our database. we're going to use the columns average session length, time on app, time on website, length of membership, yearly amount spent, and we're going to apply our function standardize to each of those columns. So that's what that run is there. And then our new table here, ecom standardized, we're going to tell it that the ecom standardized label is the ecom label. So essentially what we're doing is we're pulling that new column we had created from ecom, we're pulling it over to this new table of standardized values. So when we do that, what we get is this new table called ecom underscore standardized dot head. And it is the columns that we have standardized. So now they have 0 as their average. And then they look at how far away they are from the average, right? So we're basically going from like -3 to +3. And then we have added that label column to this new table as well. So we have all of it here. All right, so now what we're going to do is we're going to have a sum table. So we're going to group by. So group by the label and find the average session length for this group, find the average session length for this group, find the average time on app for each of the groups. So we're going to do ecom underscore standard, that's this table, grouped by the label column, find the mean. So find the mean by the label groups for the table. We do that. What we get is our sum table, which has the average for each of these values for that group that is represented by that label. So we had 6 clusters. The average session length for this particular cluster is less than the greater average. So we get a negative number here. You can see the average session length is much higher for this label. So we can see then the average is there. We need that for our radar plot in order to show where these labels differ, because we're not plotting every data point. We're not plotting every person on this radar plot. Remember when we did our spider or radar plots the first time, you had 2 choices, right? You could do an example person from each group, or you could do the mean or the median from each group to show on the radar plot. So here we're going to do the mean of each of these clusters. Then this is the code you've seen before for the radar plot. We take our categories, which is the average session length, time on app, time on website, length of membership, yearly amount spent. We're going to use go.figure, and then we're going to add traces to it using scatter polar. And so here, this sum table dot index location 4, index location 4 is going to be cluster 5. And so that's because, remember, Python starts counting at 0. And we have cluster, unless you want to call it cluster 0, we have cluster 1, 2, 3, 4, 5, 6. So 4 is 5, 3 is 4, 2 is 3, 1 is 2, 0 is 1. Okay, so all we're changing is the name and then the index location from our summary table. And then we're going to plot it. So the rest of that code you can leave as is. Now, how come I loaded them in a weird order? How come it's, what is it, 5, 4, 3, 2, 1? Okay, that's fine. If you find that your clusters are kind of hidden, so you can't see anything because of the way they were loaded in, then you can change the order. So just change, like here I went 5, 4, 3, 2, 1. But if you're finding that you can't see any clusters, all you see is 1 because the rest are hidden underneath it, try loading them in a different order in the code. So at a quick glance, what do we see? We see that there is a cluster here where they spend a lot less each year and their memberships are a lot shorter. We can see this group here in purple has been here for more years, has a longer length of membership, spends more money, spends more time on the app and in their session length. So we can see the differences here in the clusters where we're looking at all the variables at once. And the spider radar plot is great to show all of this at once. But as great as this is, it's difficult to make decisions for our business based on all the variables at once, which brings us back to, can we just use one or two variables to then make our business decisions based on? So we need to then look at, with some scatter plots, are there clear linear splits in any of the variables that we can use to create our decision rules? So let's go back to our scatter plot. So we're going to focus on length of membership and yearly amount spent, because according to our violin plots, length of membership and amount spent were different between the labels and the other ones were not. So we're going to then here from Seaborn import scatterplot, import matplotlib as MPL, import matplotlib.pyplot as PLT, change the size of the bubbles. The key here is hue is equal to ecom label. So the labels for the data points, we want to color code based on that. And when we do that, we get our groups here. You can see the 6 cohorts here. So now we're looking at, is there a way to split these nice straight lines to give us different groups, in which case then we can use that to identify clusters of people. And so notice that, we could take a nice straight horizontal line here. Anything below, let's say 390, would be group 2. Anything between 390 and 460 is the next group. And then same thing, we could keep going. And in fact, I think I have a visual here where we can create a business rule. And that business rule would say they belong to this group if the yearly amount spent is below 390. They belong to this group between 390 and that 460. And so then we can identify individuals or events based here just on yearly amount spent. And so then we can use that to put them into their cohort, into their cluster, and then we can make decisions based on them. So maybe that cluster has a name. We have the frequent spenders. We have the ones who live on our app. We have, the newbies, whatever you want to give them names so that they are then identified by that group. And then your decisions within your organization are geared towards those different clusters.